Yes, good evening. Again, I'm happy to welcome you to this our class of Construction Management 2, and we want to continue from where we left, where I told you we are going to continue from the critical path methods. So we say this when we talk about the critical path methods, it means we have to give a good project plan from the starting to another. Then another thing that you have to consider when planning using the critical path methods, all the activities should be done according to the stages of construction. For example, if you want to do the excavations, maybe you are given activity of excavation, then again you have activity for foundationing, then you have the activity for walling, then you have to make this activity the way from the construction, since you know that then again we can have the plastering, that's what they say, they can say tiling. So it means you have to arrange these things according to the way the normal construction. Since you have the excavation, you do the first one, this will be the first one. After excavation you can do what is called the foundation, will be the second one. Then you can have the walling as the third. Then you can have plastering as the fourth, and finally we have the tiling as the last one. So we have the properties of this critical path method. We say is a chart consisting of a network of all nodes and arrows. Say each arrow represents a step or a task of circular work. Again, you can say the tail of the arrow states the start of the project, while the head states the completion of an activity. For example, you can have something like this. So this one start, it means the start of the project. Then this means the completion of the project. The completion of the project. Then this one can say the project duration, project or activity duration, activity duration. For example, if you are to have excavation, and it means we have to take 4 days for us to go to another one, which is the foundationing at the end, completion of that. Then from this duration, if it was supposed to take us 3 days, then we'll have to put 3 days at that arrow. So this is called the nodes, and it's called the arrow. It's called the arrow. So another properties of this, we say it's designated by the two number at the head, always greater than the number at the tail. It means so the number at this point will be more than, but at the tail. Then another property, we say the length and the shape of the lines and the arrow does not give any significant. Again, talk about what is called the terminologies that can be used in critical path method network. You can have an activity and say this is the performance of a particular task, such as placing of reinforcement steel, time which is required for a particular activities, and it's noted by an arrow. Then you can have another term which is the event, say represent the completions of activity which consumes no time. It consumes no time and it's indicated on a network number. Then you can have what's called the network, where you say it's a diagram showing the relations of activities and events of the project. Then you can have what is a dam, the dam, and say it's an artificial activity represented by dots of line. Maybe from activity A to activity B. Then we have the dummy. It means it is this activity can be done subsequently at the same time. Then we have what is called the durations, and we say is the estimated expressed in any defined unit in hours or days or weeks, which is required to perform an activity. We call it durations. So it means this is the time that we have to take for us to come from one activity to the next activity. We call it durations. Then you can have what is called the earliest time. say this is the earliest time at which activities can be started. It means the earliest starting time, the time that activity can be started. Then we have the earliest finished time, and say this is the earliest time that an activity can be finished. And it's always given us earliest finished time, and have earliest finished time is equals to earliest start time plus duration. Earliest start time plus durations. That is how it is to get. So when you're asked to get durations, it means durations is equals to earliest finish time minus earliest starting time. That's how we get it. Then we can talk about where we have the latest start, and say is the latest time that an activity may be started without delaying the completions of the project. It means at this time we can start it at that time, then without delaying the subsequent activities. Then we have the latest finished time, saying this is the latest time in which the activity can be finished without delaying the completions of the project. And say latest time is equal to latest plus duration. Latest time, latest start time is equal to latest finished time plus duration. This is called latest start time. This is called latest finished time. Then this is called the duration. This is called the duration. Then again you can have what is called the float, and say is the difference between the available time to do the job and the time required for that time to be completed. They say the total float is always given as this is called, give it total float, abbreviated as total float. Then again what we have what is called the free float. We'll say this is the amount of time by which the activities can be finished without delaying the earliest start of this activity. So we say free float is equals to earliest start minus earliest finished. Free float is equals to earliest start minus earliest finished time. Earliest finished time. Earliest start time minus earliest finished time. Then we can have what is called the critical path, and say it represents a series of activities that has a zero float time. And again you can say it determines the maximum time required to complete the project. Then you have what is called the forward paths. When we talk about the forward path, it means it states the earliest time which activities can be finished and additions of the durations that this activity will have to take before the next activity begins. Then we have the backward pass. Say it starts with the earliest finish time of the final available time for it to continue with the computations of the allowable time for the next activity. Then we can have an example that will help us to understand more of this example on how we can do this and more and more.